Okay, so hello everyone. My name is Eileen Pan from the University of Sheffield, and it's great to take part in our final TAPAS workshop. I'm currently in China, so I will start my presentation remotely. The project I will talk about today is the detecting cognitive decline related to dementia. First of all, I will introduce the research background briefly. So in 2020, around 50 million people worldwide were living with dementia, and this is predicted to almost double every 20 years. And as we know, dementia is incurable, but early detection enables early treatment that can slow down and maintain mental functions. People with memory problems will typically go to their GP first and are then referred to the secondary care for further tests, which is actually unnecessary. And generally, it takes a long time for the whole process. And even though memory is the main symptoms of dementia, language and speech are also affected at the early stages. So let's have a look about the effects of dementia on speech. It can be summarized into three parts: the articulatory character, and vocal quality, and the prosodic character. For example, the articulators include the lip tone and larynx, for example, and the articulatory movement can be affected by dementia. So the effect of dementia on language can be summarized into word level and sentence level. The word level including the change on vocabulary size, information units, the number of words, and the unique words in speech. And for the sentence level, it includes like the amount of meaningful information covered in sentences and the contextual relevance between sentences. So considering these effects, what are the current diagnostic procedures? The current diagnostic procedures, including the following parts, and but it has some drawbacks. It is time-consuming. It always takes a very long time for the whole procedures, and the current tests at GP are not always accurate, and too many people are sent to the secondary care, as I mentioned just now. So it is not necessary. Also, some tests like blood tests, it is invasive and have difficulties on stratifications. Then they want to know how to detect dementia automatically. Let me introduce the work at the University of Sheffield. So firstly, an intelligent virtual agent is installed on the laptop, and it can ask questions. People with memory problems will answer these questions, and in this process, speech is recorded. And both the audio recordings and corresponding transcripts are analyzed automatically. So this is a very general methodology for the acoustic and linguistic-based dementia detection. And as we can see from the slide, an ASR system is always there for transcribing the audio recordings into transcripts. And we can extract the acoustic information from the audio or linguistic information from the transcript for the following up the dementia detection. So what are the questions asked for dementia detection? A very popular question is the cookie-sift picture description. As shown in the slide is a picture named cookie-sift picture. It is provided in the while doing the test, and the person with memory problem is asked to describe what she or he has seen in this picture, giving as much detail as possible. And I have put two examples from healthy control and people living with dementia, respectively. So we can see from the transcript that it held decline at word level and sentence level. For example, for healthy control, they will use mother to describe the woman in the picture. But for people living with Alzheimer's disease, they may use lady instead of mother. And we can also see the sentence from the people living with Alzheimer's disease are not really relevant to the picture. And these are the declines in the linguistic part. And for clinicians, the decline at both the word level and sentence levels are considered while doing the diagnosis. Then we need to consider how could we extract information with a designed linguistic-based system. And for the acoustic part, let's listen to the audio first. I will put the
scene is in the kitchen. The mother is wiping dishes and the water is running on the floor. A boy is trying to get cookies out of a jar and he's about to tip over on a stool.
Yeah, so I'm wondering, could you hear the audio I played just now?
We hear it, but not clearly. I increased the audio level a bit now, but I'm not sure we will hear it.
Okay, I will try to play it again.
The scene is in the kitchen. The mother is wiping dishes and the water is running on the floor. A boy is trying to get cookies out of a jar and he's about to tip over on a stool.
Yeah, well, this is the audio from the healthy control, and I will play the audio from the people living with Alzheimer's disease.
Cookie jar, the boy, the girl, the ladder, the cabinet, and the other cabinet with the sink in it, or with the water coming out.
Okay, so this is the audio from people living with Alzheimer's disease. And we can find that the speech from AD is slower and less clear, and there are more pauses. So considering these symptoms, I will introduce the designed linguistic-based dementia detection system first, and then the acoustic-based dementia detection system. So inspired by the medical diagnostic procedure, an attention-based hierarchical system is designed. As shown in the slides, the input of the system are the words in the transcript. And the yellow part is the word level feature extraction structure, and the green part is the sentence level feature extraction structure. This is a binary classification system, and the attention mechanism is used to learn the width for both words and sentences. And for understand the attention mechanism better, a manual transcript is selected to visualize the attention weights at both the word and sentence levels. The darker the color, the higher the weight. As shown in the figure, at the word level, the informative words like water and mother have a higher attention weight. And for those sentences with more informative units, they have a higher attention weight. So for testing our proposed system, the dementia detection dataset, the dementia bank dataset is used. It includes the audio recordings and manual transcripts collected from the people while they describing the cookie safety picture. And dementia bank dataset is the largest publicly available dataset of dementia detection. And in our research, only the recordings collected from healthy control and people living with Alzheimer's disease are used for the research. So we test our results on the automatic transcript generated by the ASR system. And we designed two baseline systems to test the hierarchical structure and the attention mechanism. The result shows that both the hierarchical structure and attention mechanism are beneficial for extracting linguistic information from the transcript. And next, I will introduce the designed acoustic dementia detection system. In the previous research, it has been mentioned that it is not a very good way to extract the feature directly from the whole audio recordings, especially for those include high background noise and long pauses. And as we can see from the audio recording example from the from the dementia bank dataset, that it includes long pauses, high pause rate, noisy background, and unclear. It also has some unclear pronounced words from from the people living with Alzheimer's disease. In this slide, we show not only the speech view, but also the manual transcript and also the automatic transcript from automatic transcript, confidence scores, and time alignment information estimated by the ASR system. And we can see that there's a long pause between the two subsegments, and the one mistake recognized the word it's recognized into less in the automatic transcript. So in our research, we hypothesize that the unclear pronounced words correspond to those words with a low confidence scores. And to extract the high quality acoustic feature, the pause and unclear pronounced words should be removed. To select the speech segments with high confidence scores, we use a confidence score threshold. And only the speech segments with high confidence scores are used for extracting the acoustic feature, and we use an S10 feature set as the acoustic feature set. And next we analyze the output of the ASR system. The confidence scores, time alignment information, and transcript words output by the ASR system are used to calculate the parameters shown in the table. And we can see that both the word and the pause duration are longer on average in the AD group than in the HC group. And we can also see the number of words per transcript is lower in the AD group than in the HC group. And we can also find the confidence score is higher for the HC group than the AD group. So how could we use this information for design the features for dementia detection? As we mentioned, only the speech segments with high confidence scores are used for extracting the acoustic feature. The speech segments with low confidence scores and the pause are removed. Then after we remove the pause duration and low confidence scores in the audio recordings, the speak pattern information is also removed, like how frequently the pause exists between the words and how long the pause is. So we designed a three-dimension rhythm-related feature, and we plot out this three-dimension feature in this figure, and we select 30 samples from both the healthy control and people living with dementia. We can see that our designed rhythm-related feature is distinctive between the two classes. And in our experiment part, we designed a classifier composed by bidirectional RSTM and attention mechanism. Input of the system is the S10 acoustic feature with or without the designed rhythm-related feature. As we mentioned just now, we need to select the high confidence score speech segments. For selection, the confidence score threshold is needed. Here we test the confidence score threshold. We tested how it will influence the performance of the extracted acoustic feature. And we can see from the result that our proposed rhythm-related feature is useful for improving the dementia detection system. And increase the threshold within a certain range can benefit the classification performance of the learned features. And yeah, so this is the designed acoustic-based dementia detection system. Finally, a fusion system is designed for combining the acoustic and linguistic features with the two systems I introduced just now. And we can see from the table that a fusion system can perform better than using a single modality, I mean acoustic only or linguistic only systems. And finally, I will introduce the future work. Firstly, is simplifying the acoustic system. As we have a question is, why do we really need an ASR system for extracting linguistic information from the audio recordings? As we use the word array for select the transcript, but is it really the best criteria for select the best transcript used for the back-end dementia detection system? Maybe we need to do more exploration. And second question is the second work is utilizing the pre-trained models. So in recent years, BERT and Wheel Tractor are started to be used for extracting the linguistic and acoustic information for dementia detection. And how to use these pre-trained models on the small sets publicly available dataset for dementia detection. And finally, is constructing the longitudinal structures. So as we know, the longitudinal tracking is very practical, but limited research has been done on this field. So whether we could construct a longitudinal dementia detection system in the future. Yeah, this is my presentation today, and thanks a lot for listening.
Thank you, Yilin. Are there any questions? Not here immediately, but online maybe? Yes, there is one here.
Yeah, thank you very much for the presentation. Very nice overview of important work. I just was a little bit lost in a couple of points. So first of all, you said that that this linguistic features only already gave you the performance of something like 77, and adding acoustic features only added very little on top of that. But then at the end, you said that future work you would look at that whether you need ASR at all. But I think it almost sounded like that you need only ASR.
Oh yeah, thanks a lot for your question. So in my research, yes, I use the ASR system for constructing the linguistic only system, and also I use it for designing my acoustic feature. But as I'm thinking, like for the speech, for the audio recordings, it also includes the linguistic information. But the ASR system, do we really need to extract the linguistic information from the transcript rather than maybe we can extract it directly from the audio recordings? As I know some research like speech, spoken language understanding, they don't really need an ASR system. They can extract the linguistic information directly from the speech. So yes, because I used ASR previously, so I want to explore in the future, maybe they don't really need it, as we have proved in our in our published paper that the transcript with longest word error rate maybe not the best transcript for the back-end dementia detection system.
Okay, so I guess you mean basically that you don't know exactly, you don't need to know exactly which words are being said, but you somehow need some sort of linguistic characterization of what is being said or how this person is talking. Something in between acoustic and linguistic in some sense would be maybe the optimal.
Yeah, that's it.
Okay, thanks.
Okay, thank you.
I have a question, if that's possible. Gwen?
Yes, perfect, Helmer.
Okay. In our Alzheimer data we've looked at, we see a lot of pauses within words, not between words, but within words. I don't know if you often see that in your data, but can you cope with it? What's the effect of this within word pauses on your results, and can you process it? Can you deal with it?
Okay, thanks a lot for your question, Helmer. So for my research, I didn't distinguish the within word pause and the between word pause. I just set a threshold like the if the estimated word alignment information, I use it, and the pause duration, if it is shorter than 0.2 seconds, I will just ignore it and only use the something like the longer pauses to calculate or to design my feature, the feature.
So if I think about it, in your method, then probably, so then you have a part of word pause, another part of word. These two part of words will be recognized as a word. And if it's a non-existing word, it will have a low confidence. And then maybe it will be discarded. Is that the way your method deals with within word pauses?
Oh, it's so part of words, you mean?
Yeah, so for instance, home. And if somebody says ho, long pause, yeah, that's a bad example. But you can think about such examples. Features, feet, long pause, earth, something like that.
Oh,
Both
I understand.
feet is an existing word, but so then you often have non-existing words, which are part of a word with a long pause in between.
Yeah, if it's under this circumstance, I think it will cannot recognize these words, and they will have a very low confidence scores.
Okay, thank you very much.
Yeah, thank you.
Other questions? Jeline, I was just wondering, patients with dysarthria or other pathological speech disorders also often reduce their sentence length and use more frequently frequent words. So I was wondering, can you distinguish between persons with dementia and a pathological speech disorder?
So for my research, I concentrate on people living with dementia, or not all specifically people living with Alzheimer's disease or not. So we also did some research on other classes, but not, I didn't introduce it here. So I'm not quite sure whether I can distinguish between like disastrous speech and the people living with Alzheimer's disease.
Okay, might be interesting to look into, to dive into in the future. Okay, thank you very much. And we move on to the next presentation.
Okay, I will stop my, oh, I have to stop it. Yeah. Thanks a lot.
Okay, thank you. Nalantihal, are you online? Skrikant.
Yeah.
Okay.
Yeah.
Okay, can you please share your slides, or should I do it?
No, I can do it.
Okay, thank you.